Hello children, today we are going to discuss chapter carbon and its compounds. First we will discuss about the occurrence of carbon. Carbon is found in atmosphere inside the earth crust and in all living organisms. Carbon is present in fuels like wood, coal, charcoal, petroleum, natural gas, and carbon is present in compounds like carbonates, hydrogen carbonates. Carbon is found in the free state as a diamond, graphite, fullerenes, etc. These all are the carbon containing compounds. That's why this carbon is very versatile. Now we will discuss about the bonding in carbon, that is covalent bond. The atomic number of carbon is 6. Its electronic arrangement means its electronic configuration is 2,4. It has 4 valence electrons in its outermost orbit. It can attain stability by gaining 4 electrons, by losing 4 electrons, as well as by sharing 4 electrons with other atoms, as well as with other heteroatoms. It does not gain 4 electrons because it is difficult for the 6 protons to hold 10 electrons. It does not lose totally 4 electrons because it needs a lot of energy to lose 4 electrons. So it shares 4 electrons with other atoms to gain stability, resulting in the formation of covalent bond. Because in the covalent bonds, sharing is there. Since carbon atom needs 4 electrons to gain stability, to fulfill the condition of stability, its valency is 4. That's why this is a tetravalent. Tetra means 4. See, 4 electrons are there in the outermost orbit of carbon. Now carbon will share other 4 electrons with same carbon atom as well as with other heteroatoms. That's why single bond is there. Now we will discuss about the formation of covalent bonds. Covalent bond is a chemical bond formed by the sharing of electrons between atoms. The sharing of one pair of electrons result in the formation of single covalent bond. One pair of electrons, then single covalent bond. And the sharing of two pairs of electron, then double covalent bond. And sharing of 3 pairs of electron results the formation of triple covalent bond. And we can represent these bonding via single line will represent single covalent bond, double lines will represent double covalent bond, and triple line will represent triple covalent bond. For example, the formation of single covalent bond in hydrogen molecule. The atomic number of hydrogen is 1. Its electronic arrangement is 1. It has one valence electron and it needs one more electron to gain stability. So, two hydrogen atoms share one pair of electron resulting in the formation of single covalent bond in hydrogen molecule. This is the hydrogen atom, this one is hydrogen atom. Both contains one electrons. Now, these both hydrogens will share one pair of electron. Here, sharing of one pair of electrons, that's why single bond is there and we can represent single bond with the help of single line. Now we will discuss the formation of double covalent bond. For example, oxygen molecule. The atomic number of oxygen is 8 and its electronic configuration is 2, 6. It means in the outermost orbit of oxygen, 6 valence electrons are there. It needs 2 more electrons to attain stability. So, two oxygen atoms share two pair of electrons, resulting in the formation of a double covalent bond in oxygen molecule. This is an oxygen atom. This is also another oxygen atom. When both oxygen atom will combine, that time both oxygen atoms will share two pairs of electrons. Two pair of electron sharing is there. That's why we can represent this double bonding with the help of two lines of between the carbon atoms. So this is the example of oxygen. Now we will discuss the formation of triple covalent bond in nitrogen molecule, that is N2. The atomic number of nitrogen is 7. Its electronic configuration is 2,5. So in the outermost orbit of nitrogen, 5 valence electrons are there. It needs 3 electrons more to attain stability. So two nitrogen atoms share 3 pair of electrons, resulting in the formation of triple covalent bond in nitrogen molecule. This one is a one nitrogen atom. This one is another nitrogen atom. When both will combine, that time these both nitrogen atoms will share 3 pairs of electrons, and we can represent this triple bonding by using 3 lines. This is the example of nitrogen and triple bonding. Now we will discuss some other examples like hydrogen molecule. 2 hydrogen atoms are there. In the case of fluorine, this is a structure of carbon dioxide, and this is a structure of carbon tetrafluoride. What is electron dot structure? First, we will discuss the electron dot structure of methane. In the case of methane, carbon is a tetrafluoride, tetravalent. So, in the case of tetravalency, 4 electrons are required to achieve stability. In the case of methane, carbon and hydrogen will share single pairs of electrons. Now, the other example is ethane, ANE. ANE means single bonding is there. The molecular formula of ethane is C2H6. Here also, hydrogen and carbon will share single pair of electrons. That's why single bonding is there, and we can represent this single bonding with the help of single line. Now, formation of a very large number of carbon compounds. Carbon forms a very large number of compounds. The number of carbon compounds is more than 3 millions. It is more than the number of compounds formed by all other elements. This is because carbon atom can form bonds with other carbon atom to form long chains, branch chains, and closed rings that are known as cyclic structures also. This property of carbon is known as catenation. What we will speak? Catenation. Since the valency of carbon is 4, it can form bonds with other carbon atoms as well as with heteroatoms like hydrogen, oxygen, nitrogen, and halogens. So, this is the structure of the different type of chains. This is the example of the long chain. This is the example of branch chain. And this is the example of cyclic structure. Long chain. A straight and single chain is there. So this is the long chain. Number of carbon atoms can combine. This is a branch chain. Branch is there on the carbon atom, and here also branch is there on carbon atom. So this is the example of branch chain. This is the example of the closed ring. Closed ring, as well as we can speak cyclic structure. Now we will discuss about the hydrocarbons, saturated hydrocarbons and unsaturated hydrocarbons. What are hydrocarbons? Hydrocarbons are compounds containing carbon and hydrogen atoms. There are two types of hydrocarbon, saturated hydrocarbons and unsaturated hydrocarbons. What are saturated hydrocarbons? Hydrocarbons having all single covalent bonds between the carbon atoms. Example, alkanes. In the case of alkanes, single covalent bond is there. So alkanes have all single covalent bond between the carbon atoms, and their name ends with ANE. Name ends with ANE. Here, one example, that is methane. If we will see the spelling, the name ends with ANE. So this is the example of saturated hydrocarbon. Other example, that is ethane. Here also name ends with ANE. So this is also the example of the saturated hydrocarbon. Now, this is the structure of the CH4 and this is the structure of C2H6. Here ANE, as well as we can see very clearly, then between the carbon and hydrogen only single bonding is there. So if single bond is there between the carbon and hydrogen atoms, that time we can use this ANE. Next, we will discuss unsaturated hydrocarbons. Unsaturated hydrocarbons are the hydrocarbons having a double or triple covalent bond between two carbon atoms. For example, alkenes and alkynes. What are alkenes? Alkenes have a double covalent bond between two carbon atoms and their names end with ENE. Their name ends with ENE. So here we can see the example, that is ethene. Name ends in EN. Name ends with ENE. Here example, that is ethane. We can see the name ends with ENE. So the molecular formula of ethane is C2H4. Other example is propane. Name ends with ENE. So in the case of alkenes, name ends with ENE and double bond is there. Other is alkynes. Alkynes have a triple covalent bond between two carbon atoms and name ends with YNE. If triple bond is there, then we will use YNE. For example, ethine, name ends with YNE and the molecular formula is C2H2. Here, triple bond is there. Another is propine. Propine, C3H4, name ends with YNE and triple bond is there. Now we will discuss about the isomerism. What is this isomerism? Carbon compounds having the same molecular formula but different structural formulas are called isomers. And this property is known as isomerism. Like butane. The formula of butane is C4H10, has two isomers. They are normal butane and isobutane. This is the structure of the normal butane and isobutane. This is normal butane. Only single structure is there. And this is the example of structure and example of isobutane. Now we will discuss another example like pentane. The formula of pentane is C5H12. C5H12 has three isomers. They are normal pentane, isopentane, and neopentane. This is the structure of normal pentane. This is isopentane, and other example is neopentane. Now we will discuss about functional groups. What are these functional groups? An atom or group of atom which decides the properties of carbon compound is called functional groups. Like halide. Halides are known as halo group also, like chlorine and bromine, etc. And name ends with ANE. For example, CH3Cl means chloromethane, C2H5Br means bromoethane. Alcohol, OH, names ends with OL. Name ends with OL. Like example, CH3OH, methanol, and C2H5OH, that is ethanol. Aldehydes like CHO, names end with AL. HCHO like methanol, CH3CHO like ethanol. Next is carboxylic group, that is single bond COOH, and name ends with OIC. Names end with OIC acid. Example, HCOOH like methanoic acid, and CH3COOH ethanoic acid. Next is ketone, like single bond CO. Names end with ONE. Names end with ONE. Example is CH3COCH3. That is known as propanol. Another is CH3COC2H5. Name is butanol. Now we will discuss about homologous series. Homologous series is a group of carbon compounds having similar structures, similar chemical properties, and whose successive members differ by CH2 group, like alkanes, alkynes, alkenes. Alkanes have a general molecular formula, that is CnH2n plus 2. Their names end with ANE and the members are methane, ethane, propane, butane, pentane. These are the molecular formulas. Methane CH4, ethane C2H6, propane C3H8, butane C4H10, and pentane C5H12. This is the structure of methane. This is the structure of ethane and propane. Now we will discuss about alkenes. Alkenes have a general molecular formula, that is CnH2n, and their name ends with ENE. The members are ethene C2H5, propene C3H6, butane C4H8, pentane C5H10. This is the structure of ethene. And other example is propane and butane. Now we will discuss about alkynes. Alkynes have a general molecular formula, that is CnH2n minus 2. CnH2n minus 2. Their names end with YNE and the members are ethine C2H2, propyne C3H4 and butane C4H6. These are the structures of the members of alkyne series. Now we will discuss about some chemical properties of carbon containing compounds. First is combustion. What is combustion? If we'll burn something, that is known as combustion. So carbon compounds burn in oxygen to form water, carbon dioxide, heat and light. When carbon reacts with oxygen, then carbon dioxide will form and heat and light will evolve. When methane reacts with oxygen, then water, carbon dioxide will form and heat and light will evolve. Same in the case of C2H5OH, water, carbon dioxide will form and heat and light will evolve. Oxidation, carbon compounds like alcohols are oxidized to carboxylic acids on heating with oxidizing agents like alkaline potassium permanganate, KMNO4 or acidic potassium dichromate, that is K2Cr2O7. For example, alcohol are oxidized to carboxylic acids. Like C2H5OH will heat in the presence of alkaline KMNO4, then ethonic acid will form. Next is additional reactions. Unsaturated hydrocarbons undergo additional reaction with hydrogen in the presence of nickel and palladium as a catalyst to form saturated hydrocarbons. For example, ethene undergoes addition reaction with hydrogen to form ethane in the presence of nickel and palladium as a catalyst. So C2H4 when reacts with hydrogen, then C2H6 will form. The addition of hydrogen to unsaturated hydrocarbons to form saturated hydrocarbon is called hydrogenation. It is known as hydrogenation. Hydrogenation is used to convert unsaturated oil and fats to saturated oils and fats. Substitution reactions. Saturated hydrocarbons undergo substitution reaction with halogens to form substitutional products. For example, methane undergoes substitution reaction with chlorine in the presence of sunlight to form products. Like CH4 when reacts with Cl2, then CH3Cl will form and HCl will produce. Same in the case of CH2Cl. CH2Cl2 reacts with chlorine, then CHCl3 and hydrochloric will form. Same in the case of CH3Cl will react with the Cl2, then CH2Cl2 and HCl will form. In the case of CHCl3 reacts with the Cl2, then CCl4 and HCl will form. Some important carbon compounds like ethanol. Formula is C2H5OH, is known as ethyl alcohol. Properties: ethanol is a colorless liquid with a pleasant smell and burning taste. It is soluble in water. Ethanol reacts with sodium to form sodium ethoxide and hydrogen, like C2H5OH plus Na, then C2H5ONa plus H2. Ethanol reacts with a hot concentrated sulfuric acid to form ethane and water. Concentrated sulfuric acid is a dehydrating agent and removes water from the ethanol. This is known as dehydration reaction also. So when C2H5OH reacts in the presence of sulfuric acid, then C2H4 will form and water will separate. The uses of ethanol. Ethanol is used for making alcoholic drinks. It is used as a solvent and it is used for making medicines like tincture iodine, cough syrups and tonics. Now we will discuss about ethonic acid. The formula of ethonic acid is CH3COOH. Common name is acetic acid. The properties of ethonic acid. Ethonic acid is a colorless liquid with a pungent smell and sour taste. It is soluble in water and a solution of 5 to 8% ethonic acid in water is known as vinegar. Esterification. Ethonic acid reacts with the ethanol to form the ester ethyl ethonate in the presence of concentrated sulfuric acid like CH3COOH plus C2H5OH in the presence of sulfuric acid. CH3COOC2H5 will form and water will separate. This reaction between carboxylic acid and alcohol used to form esters, and this reaction is known as esterification. Saponification. When an ester reacts with the sodium hydroxide solution, the sodium salt of the carboxylic acid and the parent alcohol are formed. This type of reactions are known as saponification. For example, ethyl ethonate reacts with sodium hydroxide to form sodium acetate and ethanol, like C2H5C, CH3COOC2H5 plus sodium hydroxide NaOH, then CH3COONa, sodium salt will form and ethanol will separate. Ethonic acid reacts with base to form salt and water, like CH3COOH in the presence of a sodium hydroxide form CH3COONa and water will separate. That is CH3COONa, this is sodium salt and water will separate. Ethonic acid reacts with a carbonate and hydrogen carbonate to form salt and water and carbon dioxide as a product. Like reaction CH3COOH, then Na2CO3 will react, then product is CH3COONa, water and carbon dioxide. Same in the case of CH3COOH will react with the NaHCO3, then CH3COONa, water and carbon dioxide will form. Now we will discuss soap and detergents. What are these soap and detergents? Soap are a long chain of sodium or potassium salts of carboxylic acid, like sodium stearate. The formula of sodium stearate is C17H35COONa. Structure of soap molecule. A soap molecule has two parts, a long hydrocarbon part which is hydrophobic, means water repelling and soluble in oil and grease, and a short ionic part which is hydrophilic, water attracting and insoluble in oil and grease. This is a small part, this is a long part. This is water repelling part, that is known as hydrophobic. This is water attracting part, this is ionic part, which is known as hydrophilic. Cleaning action of soap. When soap is dissolved in water, it forms a spherical structure of different type of ions that is known as micelles. In each micelle, the soap molecules are arranged rapidly such that the hydrocarbon part will towards the center and the ionic part is towards the outside. The hydrocarbon part dissolve the dirt like oil, grease and forms an emulsion at the center of the micelles, which can washed away with the help of water. Like this. These are the soap molecules. This long part is in the contact of a dirt and this small part that is known as soap reacting. Now, when this long part will mix with oil and grease, this time oil and grease becomes dissolved. Then when we are putting water, this time this ionic part will work and dirt and dust will wash. Now, detergents. What are these detergents? Detergents are the long chain of sodium salt of sulfonic acids. Soap does not wash well with hard water. It forms a insoluble precipitates of calcium and magnesium salts in hard water. And the hardness of water is only because of the presence of calcium and magnesium ions. Detergents wash well with hard water because it does not form insoluble precipitate of calcium and magnesium salts in hard water. Now we will discuss the difference between the soap and the detergents. Soap are sodium salts of fatty acid, but detergents are the sodium salts of sulfonic acid. Soap cleans well in soft water but does not react properly with hard water. But detergents clean well with both hard and soft water. Soap does not clean as well as detergents. Detergents clean better than soap. Soap are biodegradable and do not cause pollution. Some detergents are non biodegradable and are responsible for pollution. So, dear children, this is the description of the chapter Carbon and its compounds. Thank you.